So for people who have joined we'll start in a few minutes. Just wait for others to join also. Then we'll start the session. Maybe we'll start now. So good evening, everyone. This is the third week session for the course Integrated Waste Management for a Smart City. I'm Abhishek Raj, PMRF scholar in Department of Civil Engineering, IIT Madras. So we'll start with the outline of this week. So we'll start with the overview for the third week. What was the content covered in the lectures? Then we'll see some practice assignment questions and we'll also take up some doubts. So coming to the overview of week three, firstly we had lecture one. So let us concern with thermal characterization of waste. So there we learned how to find the heating value of the waste material, mostly organic value can be found. It is also called as calorific value. So that helps us to judge that how much energy the waste will produce per unit of mass. Then we have the introduction to chemical analysis. So that considered the chemical composition of waste. Followed by this was lecture two. So there we studied the different types of instruments that are used for analyzing uh, municipal solid waste. So there, what are the steps involved before analyzing? That also we did. Yeah. which includes sample preparation and other things. Then we studied the QA/QC plan. So QA/QC is nothing but quality assessment and quality control. So we need to ensure certain standards when we are doing these experiments and analysis. Then we had the third lecture that was concerned with the method detection limit. So what is MDL? It is the minimum value that a machine can detect with accuracy, a decent level of accuracy. So then we had the common lab instruments which are used. This included spectrophotometers and other experiments. Then in lecture 4, we had how do we work with concentrations? What are the units that we use? Followed by this, we had the statistical analysis. Then we had lecture 5, where we was mainly about the MSW rules of 2016. So what is the organizational structure presently in India for solid waste management? This was followed by the duties of different stakeholders. So who are the stakeholders? We have the waste generators, which includes the public. We have the government. And then we have the recycling units or companies which take in recycling waste. Then we also have the other landfill operating authorities as well. So coming to the first question, so this is a poll. The question is, what is the heating value of ethanol? So given options are 20,000 BTU per pound, 21,000 BTU per pound, 12,000 BTU per pound, and 31,160 BTU per pound. So I will drop a poll, Gmail, and also answer in the chat. So I will give you around maybe 3 minutes for this, since this is a numerical. It'll take some time to solve. Take your time and solve it correctly. I will even give a hint, so you need to use the Dulong's equation. You can also answer in the chat. Has anyone attempted on the poll? So we don't have any response in the poll yet. Anyone who tried the question, so you can answer in the chat as well as the poll. So we have one response in the poll. We have two responses in the poll. Okay. We'll discuss the answer for this. So we'll see this from the very basics. No issues. How is ethanol formed? So we have ethane. So ethane is C2H6. So we have two carbons. It's attached with single bonds, and then we have six hydrogen. So what we do is we replace the hydrogen with a hydroxyl ion. So that forms two carbons. We'll still have the three hydrogens, the two hydrogens on this carbon. And finally, we'll have a hydroxyl ion here, OH. So what essentially happens is we add a oxygen. So if you see it in blunt way, so we just added one oxygen atom. So ethanol is given as C2H5OH because we have two carbon, five hydrogen and one hydroxygen. So first, to use the De-Long's equation, in order to find the heating value, we need the molecular weight of this compound. So carbon is 12, so that would be 12 into 2. Then we have hydrogen, so its weight is 1. So we have 5 atoms of hydrogen. Then we have hydroxyl ion. So hydroxyl ion would be 16 and plus 1, 17. So we have one oxygen that is 16, one hydrogen that is 1. So this would become 24 plus 5 plus 17. This would become 46. Whatever unit you want to take, you can take. 46 grams, it can be micrograms, but it will be 46 units of it. Then we need to find the percentage of each of the components, each of the atoms present in the compound. So we'll start with the percentage of carbon. So we need carbon. For De-Long's equation, we need carbon, hydrogen, oxygen, nitrogen, and sulfur. So here we don't have nitrogen and sulfur, we only have CHO. So we'll find their percentage. So percentage carbon, percentage hydrogen, percentage oxygen. So starting with carbon. So we can see we have two carbon atoms here. So that would be 12 into 2, 24. This we will divide by the total molecular weight, that is 46 into, we'll multiply this with 100. So how much would this be? This will be around 52.17%. Then we need the percentage of hydrogen. So we have 5 and 1, 6 hydrogen atoms. So that would be 6 divided by 46 into 100. So this would be around, I think, 13 to 14%. Yeah, so this is 13.04%. Next, we need the percentage of oxygen. So we can do it both ways. Here we only have three atoms, carbon, hydrogen, and oxygen. So either we can take the weight of oxygen, that is 16 by 46 into 100 we can do, or we can simply subtract the above two values from 100 because we only have three components. So together they need to add up to 100. So on subtracting this, we would get, this is 52.17. So this would give us around 34.79%. So we have the percentage of carbon, hydrogen, and oxygen. In order to use the De-Long's equation, so we need whatever values we need, we have them now. We will go to the next slide to see the equation, and there itself we will solve for the final answer. So here you can see the heating value equation given by Dulong for a waste. So it is 145 into percentage carbon plus 610 into H minus 1 by 8 of O plus we have sulfur and nitrogen as well. So as we saw, we have 145 into carbon. So how much was carbon? So carbon was 52.17. We'll substitute the value here. Then we have 610 into hydrogen. Hydrogen was I think 34. No, it was 13. So 13.04 minus 34.79 was oxygen, I think, divided by 8. So when you solve this, this would be around, let's do this, 145 into 52.17. So this comes out to be around 7564.6 plus we have the next component. So that is 13.04 minus 34.79 divided by 8 into 16. So this turns out to be 5301.66. So we'll add them. So that will become, it will be around 12866.26. So approximately you can do it 12866.3. And what will be the units for Dulong's equation when you substitute the values of the different components in percentage? So that will be British thermal unit, abbreviated as BTU, divided by per pound. So the answer is option C, 12,866.3 BTU per pound. So students can refer to week 3 lecture 1 for this concept. We'll move on to the next question. So this was a long one. Hopefully the other will be a shorter question. So question 2. The carbon content which is left after the volatile materials are driven off is called fixed carbon, volatile solids, ash, and we have water. So we will have what is called as virgin carbon in the waste. So when we try to heat this waste up to derive energy from this, so we will be left with two things. So one will be the volatile part of carbon, which will be in form of mostly biodegradable compounds, and one will be the fixed carbon. So this volatile part from the heat, it gets driven off. So like it will get converted to energy and other such forms, but the fixed carbon will still remain. So this is sometimes related to ash also, but it can't be directly called ash because ash is like a small part of it. So ash is like finally after burning everything, whatever remains, that is ash. But here we are not subjecting it to so high heat values. So here we call it fixed carbon. So whatever is left after the volatile materials are driven off is called fixed carbon. It is option A. So option A, fixed carbon. So students can refer to the first lecture of third week. So here when we talk about the waste composition for combustion potential characterization, that is the heating value. So fixed carbon content is the carbon found in the material which is left after the volatile materials are driven off. So this was the second question. Moving on to question number 3. So question number 3 is, what is the preferred measurement unit for chemical concentration present in solids? The given options are milligrams per kg, milligrams per liter, parts per million, that is ppm, and ppb, which is parts per billion. So where we are trying to measure concentration, that is. So there are two methods. So one will be that the element is present in a liquid form. So that is the solvent part is a liquid. Then we will have the element which will be present in within a solid or maybe a semi-solid form also. So where the solid is the solvent or the dissolving matter. So when we have a liquid, we will have some units of mass for the compound which we are analyzing divided by the liquid. So how do we take a liquid? How do we consider its volume? So that will be in liters. when we talk about solids, so there again, since the element will always be in milligrams or grams, depending upon how we are, what is the level of units or level of concentration that we have. But in case of a solid, we'll take the solid's mass, because volume of a solid is not a very correct parameter to choose, because volumes may change depending upon how much water is there and all. But mass is like a more precise thing to use. So we'll go with the mass of the solids. So here the concentration will be, the numerator will be in milligrams. The solids concentration we would take in kg. So that is the case for solid, and when we have a liquid as the solvent, so we'll consider milligrams per liter. So milligrams per kg, that is option A is the correct answer. So option A, milligram per kg. Students can refer to the first lecture of this week. So here we are talking about the concentration units. So most common units that we will encounter in almost all the cases. So when we are considering like liquids or wastewater, where a liquid is the solvent, so there we'll use the unit milligrams per liter. And when we are using solids, where the solid is the main matter, that is the solvent, so there we would use milligrams per kg. Moving on to question number 4. Question 4 is, the method detection limit can be determined by using the following equation, where T is the one-sided critical value, N is the number of sample, and S is the standard deviation. So how is the MDL found when these parameters are given? So the first is T plus S, where T is for n minus 1 degrees of freedom and alpha is 99%. Next we have T into S. So here we are taking degree of freedom as n itself. Third option C, we have T plus S, but again we are taking degree of freedom as n. And finally the last option, that is D. So T for degree of freedom n minus 1 and 99% alpha into S. So when we are trying to find, and we are trying to do a statistical test of T, so usually it is taken as the mean plus the T value into standard deviation, that is S. But what happens in case of MDL is, so it is the minimum value of concentration which your instrument can detect. So usually MDL will be very close to 0, because modern instruments are very precise. They can measure up to very low concentrations. So if you ignore the decimals or whatever is there ahead of the points, it will be very close to 0. For simplicity's sake, let's consider it as 0. So the mean concentration or the value that we are going to get when we are trying to measure MDL, it will be very close to 0 only. So we will be left with P into S. So S is the standard deviation, so that we have been given here. So what is left is P. So it should always be remembered in t-test that degree of freedom is n minus 1. So what is n? N is the sample size. And how do we consider it? Like, what is the alpha level? So we will say that 99% of the times we should be confident about the value. So alpha will be 99%, or we'll generally consider in decimal form only. So that will be 0.9. So other levels of alpha are also there, like 90%, 95% we'll use. But here, since we are concerned with, we want to be more conservative, so we'll consider it as a high value, which is 99%. So the value, that is MDL, which is X in here. So T, we will consider the degree of freedom that we just saw, n minus 1, sample size minus 1, minus alpha will be 0.99, and this will be operated with the standard deviation of the test values. So that we can see that we have in the last option, that is option D, T of n minus 1 and alpha of 99% into the standard deviation, which is option B. So coming to the next slide, that is the answer for this. So yeah, option D, T of n minus 1, 99% alpha into S. students can refer to the third lecture of this week. So here T is the one-sided value of, and S is the number of sample. Sorry, S is the standard deviation and N is the number of sample. So degree of freedom is taken as N minus 1 in case of a T test. Coming to the next question, that is question 5. This is a poll. Find the lead concentration on a dry weight basis of a sludge whose lead concentration is 5 milligrams per kg based on total weight and 85% moisture content. The given options are 30 milligrams per kg. So we just saw in one of the questions before that when we are trying to analyze concentration in case of solids. So as the case here is dry weight basis. So dry weight is basically the solid weight. So when we are trying to judge the concentration in solid phase, so we'll use the units milligrams per kg. So we can see the options, they are in milligrams per kg only. Second option, we have 60 milligrams per kg, 33.3 and 14. So I will drop a poll. I'll give you maybe 2 to 3 minutes for this. You can answer it in the chat also, as well as the polls. In case you have any doubts also, you can type it in the chat. You can take that now. I have one response in favor of C. Okay, wait for 1 more minute and then we'll discuss the answer. responses after that. Let's check. So we have one vote in favor of C. One has responded in the chat. If you have the answer, please respond, otherwise we'll see the answer. Wait for a few more seconds. Discuss the answer. So we have lead here. So lead is one of the common pollutants found in solid waste as well as wastewater, especially industrial wastewater. There will be a lot of lead. So we have been given with the lead concentration, which is 5 mg per kg. So we have 5 mg of lead, which can be divided by 1 kg of wet. What is the solvent here? So yeah, this is sludge. And this we will operate with 1 kg of wet sludge. So whatever we had here, we just simply put it here also. And in 1 kg of wet sludge, how much would be our, that is sludge on a solid basis or dry sludge, as we call it. So here we are given that it is 85% moisture. So if we have 100 grams of sludge, that is wet sludge, so 85%, that is 85 grams would be water content, and whatever remains, that is 15 grams, would be the solid content. So when we have 1 kg of wet sludge, so we would have around 0.15, that is 15% of 1. So this much will be kg solid sludge. So 5 mg of lead in 1 kg of wet sludge. So it was given here. So sludge whose lead concentration is 5 milligrams per kg. What was the second information that was provided? That is, the sludge has 85% moisture content. So this we use to convert wet concentration to dry. So 1 kg of wet sludge divided by 0.15 kg of solid sludge. So here we can see this and this would get cancelled out. So we'll have 5 mg lead divided by 0.15 kg, that is called solid sludge. So this would be around 100 over 3 mg, and the denominator unit is kg. So 100 by 3 will be close to 33.3 milligrams per kg. So that is option C. So it should be noted here that when we were considering wet sludge, so there we had the concentration only 5 mg per kg. But when we took the sludge on a dry weight basis, that is the solid sludge, so the concentration increased by almost 6 times. So this indicates that the concentration of these critical pollutants will be much higher in case of sludge on a dry basis. So in any kind of processing or industrial process where sludge is being dealt with, so the solid sludge should be dealt with a high precision and high care, because the concentration is much higher and the risk will also increase accordingly. So option C, 33.3 mg per kg. Students can refer to the 4th lecture of this week. So here another example was given. So here we had arsenic. So that was given as 0.6 mg per kg moisture sludge. Moisture content was 80%. So we took 0.6 milligrams of arsenic by 1 kg of wet sludge. Similar, we'll do operation. We'll put it here also. So 1 kg of wet sludge, and we'll be left with. So if we have 1 kg wet sludge, so here moisture is 80%. So 0.2 kg would be the dry sludge. 0.2. So 0.6 by 0.2, that would be around 3 milligrams of arsenic per kg of dry sludge. So this is how we approach this problem. We'll see the next question, that is question 6. Observe the following data points shown in the image and match them correctly. So we are given 4 options here. As you can see the figure here. So we are given the figure and we need to match them. So we have one set is the number, that is 1, 2, 3, and 4 on the top. And this number is connected with the diagrams. So this is the diagram that is given. And then we have the letters A, B, C, D, which are these characteristics, so accurate and precise. So here we can see, if we consider the first one, so we can see all the points are on the bullseye. So all the points are in the bullseye. It means there is high precision. So whenever the point is being detected, it is in the center, and also there is accuracy is very high. So it is always in the center, which is considered as the highest accuracy. So when we see one, it should connect with accurate and precise both. So one gets connected with C. Next, let's check two. So two is where all the points are clustered. So whenever clustering is happening, so that is precise. It means whenever we are trying to detect, it is happening in the same zone. But here we can see it is far away from the center. It's like almost near the outer ring. So this is precise, but it is not accurate. So that is A. So here we can see 1C and 2A. So I think C will be correct. So, but we'll discuss the other two also. So in 3, so there is a scatter. So it's not very precise. So not precise, not precise. But we can see that they are relatively closer to the center. So if we triangulate them, like on an average, they are almost at the center. So they are accurate, but they are not precise because there is certain scatter involved. So 3 will go with B. Coming to the last one, that is fourth. So here we can see 1 point went outside and other 4 are also almost at the outer ring. So we don't have accuracy. They are far away from the center. Also, we don't have precision because there is scatter. So it is not accurate as well as not precise. So 4 will go with B. So we have C, A, D, B. So C, A, D, and so that is option C. So the answer is C. So students can refer to the third lecture of this week. So if the variability among the data is less, that is the scatter is less, then the data is said to be precise. And if the data points are closer to the target value, so as we saw in the previous case, so what is the target value? It is the center of the circles. So then the data is said to be accurate. So when you have less scatter, it is precise. When you are closer to the target value, that is your error is less, so data is accurate. We'll see the next question, that is question 7. So spectrophotometer measures of the sample to measure the chemical concentration. So emission of light, heat, absorbance of light at a specific wavelength, and conductivity. So actually the answer lies in its name itself. So the first word is spectro. So spectro comes from the word spectrum. So what does have a spectrum? Light has a spectrum. So this is concerned with light. And how do we classify the spectrum of a light? So you will be knowing there will be, I think, 7 colors. So Webber, so it is classified on the basis of wavelength. So depending upon what wavelength is there in the light, so we will have different colors. So all the 7 will form the combination and it will produce white light. So this measures light at a specific wavelength. So depending upon what kind of color is coming from the light, so we'll know the wavelength and we can accordingly characterize the wave. So we'll be using the absorbance. So how much the solution will be absorbing, accordingly it will produce light. That is option C. So option C is the correct answer. Absorbance of light at a specific wavelength. Students can refer to the second lecture of this week. So it can be seen here. So chemicals will be directly related to the absorbance. So the level of absorbance that we get from the solution. So depending upon that, we can find the concentration. So we'll have some color change. From color change, we'll have the standard tables from where we can compare for this much wavelength, this color occurs. So that can be measured using. So this is done in spectrophotometers. Coming to the next question, question 8. The chemical analysis report of a wastewater sample reads the dissolved oxygen content in the sample as 0.30 and 4%. What is the equivalent concentration of DO in milligrams per liter units? Given options are 400 mg per liter, 4 mg per liter, 40 mg per liter, and 0.4 mg per liter. So a simple way to approach this is whenever we are given X% and we need to convert this into ppm units. So what we should do it, we should simply operate this with 10 to the power 4. So here that could become x into 10 to the power 4 units of ppm. So why is this done? Because percent means like how much fraction in 100 units we have. Okay. So from here we need to take it to a million. So we have already had 2 zeros here. So when we add 4 zeros, so that would become 6 zeros. So that would be parts per million. So that is the like a plain logic behind doing this. So here we had 0.3 zeros and 4 in percent. So we'll operate this with 10 to the power 4. So this is nothing but 4 into 10 to the power minus 4 into 10 to the power 4. This would take it to, sorry, not ppm here. Let's change this unit. It should be mg per liter. So this is the same as ppm. Let's change it for the sake of accuracy. So this should become 4 mg per liter. So it is like grams in 10 to the power 6 units of the solvent. Answer is option B. Students can refer to the first lecture of this week. Answer will be option B, 4 mg per liter. So if we are given it in percentage, it will be 10 to the power 4 ppm. So milligram per liter is nothing but ppm, but here in this question, mg per liter was used because the concentration is for a liquid. Same, if we have a solid also, that would be ppm, but the left side would change, that is mg per kg. Coming to the next question, that is question 9. So which of the following are the elements of the conceptual waste composition for combustion potential characterization? So we have the options: fixed carbon, volatile solids, biodegradable solids, and water. So as we saw in one of the questions, carbon is two parts there will be. One will be fixed carbon, one will be the volatile solids part. Quite obvious, there will be some moisture as well. But when we are talking about this combustion potential, so biodegradable solids do not add much value there, so we don't consider it. So we will have fixed carbon, volatile solids, and water, because water is an important element when we are considering combustion potential, because as we saw, the concentration changes heavily when we consider a wet basis and a dry basis. So depending upon the concentration that we have of a certain element, accordingly will be the calorific value, as we saw from de Long's equation. So A, B, and D are. So fixed carbon, volatile solids, and water. Students can refer to the first lecture of this week. So here we can see the different elements. So we have fixed carbon. I think it is indicated by the blue color here. We have volatile solids, green color. Then we have some inorganic compounds such as glass, metal, dirt, indicated by red, ash by gray, and there is some portion of water also. So whatever will be left after the volatile solids have been driven off, that is the fixed carbon content. See the next question, that is question 10. What are the different chemical sample preparation methods? The given options are titration, mixing, acid digestion, and chemical oxidation. So when we are doing a experiment, so we need to do sample preparation. We cannot directly use the sample obtained from field. The reason behind this is that every experiment is designed for certain parameters and certain like attributes. So the raw waste that we are getting from the field may not have those attributes amplified. So in order to like correct the waste or modify it as per our needs so that we can detect what we want, so we need to do sample preparation. So there will be two parts to this. First will be a physical preparation that would include grinding, and then will be some chemical preparation. So chemical preparation includes we'll do some solvent digestion, we'll do acid digestion. So acid digestion is done when waste is generally very alkaline, and some chemical oxidation also we can, depending upon our waste that we are trying to get or the test we are trying to use. So titration is not a sample preparation method. So this is like analysis method. So we will have acid digestion and chemical oxidation. So mixing would go into physical, not a chemical sample preparation. So when we are talking about chemical sample preparation, we'll have acid digestion and chemical oxidation. That is option C and option D. So we have acid digestion and chemical oxidation. Students can refer to the first lecture of third week. So in physical preparation, we'll mix the waste so that because waste will be quite heterogeneous. So in order to make it homogeneous, we need to mix it. We'll do some drying to remove out excess moisture. We can also do grinding to make it to like a small unit size. Followed by physical preparation, we will do chemical preparation. So there we have acid digestion, solvent extraction, and chemical oxidation. Then we will have the analysis part. So that would include titration and other things. So we'll see the next question now, that is question 11. What are the different instrumental responses that correlate the amount of chemical constituents present in the environmental sample? The given options are absorbance of light, color, temperature, and emission of light. So as we saw in one of the questions before, so when we are talking about spectrophotometer, so that considers the absorbance of light at different wavelengths. So A is correct. We don't directly consider color. Color is indicative parameter, not tied to like the response that we are trying to study. Color won't come into that. It is a type of an indication. We are focused on the absorbance, how much absorbance will happen. The color is the result of that. Temperature is not one of them. Another will be emission. So in some of the tests, it will be focused on how much light is coming out rather than how much is absorbed. So considering this as the waste sample, so we'll pass light to this. So some of the, due to its color and inherent nature of the waste, some will be absorbed in the waste itself and some will be emitted further. So depending upon what waste components absorb the light, we can analyze for them. And depending upon what are the waste components which will reflect it, so that would go into emission. So based on both the parameters, emission and absorbance, we can find required components in the waste. So we'll have A and D. The answers are A and D, absorbance and emission. So many different instruments have been developed to measure the concentration of pollutants. So the instruments will give a response that correlates the amount of sample. So type of responses will be sometimes conductivity will increase, absorbance of light and emission. So how much is getting absorbed, how much passing through or it is getting emitted. Coming to the next question, that is question 12. So assuming you measure the lignin content of the yard waste in the laboratory using an instrument, the method detection limit for the analysis is determined as 0.1 ppm. The instrument shows the result as 0. How could you report this value? So we have the options here. You will report the value equal to detection limit. You will report the value as 0. You will report the value as half of the detection limit, and you will report the value as twice the detection limit. So we saw in one of the questions, so MDL is the minimum possible value that an instrument can measure with like a reasonable amount or a high accuracy, below which we can't really trust the values that it is giving. So here we will see MDL is 0.1 ppm, but we can see the reading as that the instrument is giving us 0 ppm. So it is below the MDL. So we cannot really trust this value because it is lower than the MDL, that is the limit, detection limit of the instrument. So there are namely 3 approaches that we go for in these cases. So firstly we'll go with 0 itself. So we'll say that okay, it is giving 0 and we'll take directly this value. So this can be done when the pollutant is not very critical. We won't worry about its concentration. So we'll directly go with 0. So we'll report the value as 0. So that is one of the correct ones. Next we'll go with the detection limit. So we'll say that okay, this much we can predict precisely, and we'll go with this value. We want to go below than this. We'll just report what the machine can report correctly. So you'll report the value equal to the detection limit. So this is also correct. That is option A. Third will be kind of the average of option A and B. So in the first, we were reporting the value as 0. Then we have MDL, which is a value greater than 0. So what we will report is the average. So average would be 0 plus MDL by 2. So it will be half of the detection limit. So you'll report the value as half of the detection limit. So that is option C. There is no point in going as twice the detection limit because going closer to the detection limit is better rather than being above it, because we know that the value is below it, or it can be 0.1, it can be between something between 0 and 0.1, but it would definitely won't be twice the detection limit. So D is incorrect. So we have the correct options as A, B, and C. So you will report the value equal to the detection limit. You will report the value as 0. You can report it as the average, that is 0 plus MDL by 2, which will be half of the detection limit. So students can refer to lecture 5 for this. So how do we handle samples when we are getting a value below the detection limit? You can assume 0, assume detection limit, assume half of detection limit, and sometimes we'll also go for other statistical approaches. So we come to the last question of today's session, which is select the correct statements regarding the duties of the Ministry of Environment and Forest and Climate Change. So the ministry is not responsible for monitoring the implementation of MSW rules in the country. Central Monitoring Committee shall meet at least once in a year to monitor and review the process of MSW implementation across the country. Central Monitoring Committee shall be renewed every 3 years. And finally, we have Central Monitoring Committee shall be renewed every year. So maybe we'll do a poll for this since this is the last question. So this is question number 13. You can also drop your answers in the chat. If the poll is live, you can enter your responses. This is from the last lecture, lecture 5, I guess. So how do we, what are the duties of stakeholders and what are the guidelines, regulations they need to follow? You can enter your responses in the chat as well as the poll. So we have one vote in favor of option C. Okay. Any other responses? We'll wait for maybe one more minute and then we'll discuss the answer. Do we have any more responses? Okay, so we have one vote in favor of C. No issues. We'll discuss the answer. So here we are talking about the duties of the Ministry of Environment and Forest and Climate Change. So MSW rules come under Ministry of Environment only. So environmental issues. So it is not responsible for monitoring the implementation. So this is wrong. They are responsible. So option A can be eliminated. Then we have Central Monitoring Committee shall meet at least once in a year to monitor and review the progress of implementation across the country. So this is correct. They do meet once a year for reviewing the progress in different parts of the country, what projects got implemented and what is the present status. Then the committee shall be renewed every 3 years. So yeah, based on the progress and what got done in 3 years. So some revamping will be done in the committee. So that is option C is also correct. Committee shall be renewed every year. No, this is not correct. So also from logistic point of view, renewing a committee every year does not make sense because that will not be very efficient. So once every 3 years is usually done. So we have the correct options B and C. So monitoring committee shall meet once a year to monitor and review the progress of implementation across the country. It should be renewed every 3 years. So option B and option C are correct. Students can refer to the last lecture, lecture 5. So here we can see in the slide also. So they meet once a year to monitor the review and it is renewed every 3 years. So here it can be seen they are responsible for monitoring the implementation. So this was the last question. We can take some doubts now. Else, if you don't have any doubts, please feel free to leave. If you have any doubts, you can type it in the chat. If you don't have any doubts, please feel free to do. We will meet again on next Saturday. Wait for maybe a couple more minutes and then we will close the session. So if you have any doubts, please ask. Okay, so we will end the meeting. We meet again next week.